Somewhere over the mountains of Japan, a rescue helicopter hovered in the dark. Below it, in the burning wreckage of a 747, between 20 and 50 people were still alive. Rescuers could hear them. Survivors could see the helicopter lights overhead. One woman tried to wave. The pilots didn't see her. Then the helicopter turned around and flew away. Those people would spend the entire night on that mountain. And by the time rescuers finally arrived the next morning, almost all of them were dead. This is the story of Japan Airlines Flight 123, the deadliest single aircraft accident in human history. 520 people died. But here's the thing that keeps investigators up at night. The crash itself didn't kill most of them. What killed them was a decision made on the ground. And the decision that started all of it was made 7 years earlier in a maintenance hangar by a Boeing technician who installed one too few rows of rivets. One row, 520 lives. This is how it happened. August 12, 1985, Tokyo's Haneda Airport. It was one of the busiest travel days of the year in Japan, Obon, the Buddhist holiday when families return home to honor the spirits of their ancestors, had transformed every train station, every highway, and every airport terminal into a sea of people, moving with quiet urgency. There were gifts to carry, grandparents to visit, incense to light. Japan was, for a few days, going home. At Gate 18, Japan Airlines Flight 123 was boarding for Osaka. It was a 50-minute flight, a commuter hop, barely longer than a bus ride across the city. Most passengers barely glanced at the aircraft as they filed down the jetway. If they had looked up, they would have seen a Boeing 747 SR. The SR stood for short range. This was a variant of the iconic jumbo jet designed specifically for high-frequency, short-haul routes. Built to be pushed hard, turned around fast, and pushed hard again, day after day, year after year. This particular aircraft, registered JA8119, had been doing exactly that for 7 years. It had logged over 25,000 flight hours and nearly 19,000 individual takeoff and landing cycles. It had flown 4 separate flights already that day. Among the 509 passengers boarding that evening was Yumi Ochiai, 26 years old, an off-duty JAL flight attendant who had caught a jump seat home after finishing a shift in Tokyo. She settled into seat 56C, toward the rear left of the aircraft, and opened a magazine. A few rows ahead, a 12-year-old girl named Keiko Kawakami sat with her parents and younger sister, heading home for the holiday. And scattered throughout the cabin were hundreds of ordinary people, salarymen, mothers with children, elderly couples, college students, all of them thinking about where they were going, not about how they were going to get there. At 6:12 p.m., Flight 123 pushed back from the gate. At 6:20, it lifted off runway 15 Lel and climbed into the hazy summer sky over Tokyo Bay, banking southwest toward Osaka. At 6:24 p.m. and 35 seconds, as the aircraft approached 24,000 feet, a sound like a cannon shot echoed through the plane. Yumi Ochiai later described it from her hospital bed. She said, "There was a loud crash from overhead and my ears hurt." At the same time, the interior of the cabin became all white. The cabin had filled with condensation as the pressurized air vented explosively into the fuselage. Oxygen masks dropped from their compartments. Sections of the ceiling collapsed onto passengers, and in the cockpit, every alarm in the aircraft began screaming at once. Captain Masami Takahashi had been flying for Japan Airlines for over 2 decades. First Officer Yoshihiro Fukuda and Flight Engineer Yutaka Sasaki were both experienced professionals. In the next 32 minutes, the three of them would fight harder than any crew in aviation history. But before we get to those 32 minutes, you need to understand something. Because what happened at 6:24 p.m. on August 12, 1985, was not an accident that began that evening. It began 7 years earlier, and it began with a mistake so small, so ordinary, that the technician who made it probably went home that night and never thought about it again. June 2, 1978, Osaka's Itami Airport. The same aircraft, JA-8119, was arriving as JAL Flight 115. The approach was slightly fast, slightly flat. When the main landing gear touched the runway, the plane bounced. The captain pulled back to arrest the bounce, and in doing so, he drove the tail of the 747 into the runway surface. The tail strike was not catastrophic. Of the 394 people on board, 25 suffered minor injuries. Nobody died. The aircraft was ferried to a maintenance base, and a Boeing technical team was dispatched to perform the repair. The damage was in the aft pressure bulkhead, a dome-shaped wall at the very rear of the pressurized section of the fuselage. Think of it like this. A commercial aircraft at 35,000 feet is essentially a metal tube being inflated from the inside. The pressure differential between the cabin and the outside air is enormous. The aft pressure bulkhead is the back wall of that pressurized tube. It absorbs that force on every single flight, thousands of times per year, year after year. If the bulkhead is perfect, this is fine. Engineers design in wide safety margins. If the bulkhead has a flaw, if it is even slightly weakened at one point, that repeated stress will find the weakness. Every pressurization cycle, the crack grows. Slowly, invisibly, relentlessly. The Boeing repair team arrived with a procedure specified in detail in the maintenance manual. The cracked section required a full-length splice plate, a reinforcing strip that would bridge the damaged area, with 2 complete rows of rivets. 2 rows, distributed across the full length of the splice. This was not optional. This was not a matter of judgment. 2 rows. What was actually installed was different. Through a process that investigators spent years trying to fully reconstruct, the splice was installed in 2 separate pieces rather than one continuous plate. This created a critical joint in the middle of the repair. And at that joint, instead of 2 rows of rivets, there was only one. 1 row of rivets where there should have been 2. Investigators calculated that this reduced the structural strength of that section of the bulkhead by approximately 70%. The repair was inspected. It was signed off. The aircraft returned to service. Over the next 7 years, JA-8119 flew 12,319 additional pressurization cycles. On every one of those flights, the weakened bulkhead flexed slightly more than it was designed to. Microscopic fatigue cracks began to form at the rivet holes, the areas of highest stress concentration. The cracks grew. Over thousands of flights, they grew longer. They spread toward each other. Multiple inspection cycles failed to detect them. By August 12, 1985, the cracks had grown long enough to connect. The bulkhead was held together by almost nothing. When the pressurization system pushed the cabin to altitude on that final flight, it found that nothing. The bulkhead ruptured. And when it did, it released energy equivalent to an explosion. The force of the bulkhead failure blew outward through the aft fuselage with tremendous violence. The auxiliary power unit was torn away. Sections of the tail cone were ripped off. The vertical stabilizer, the great tail fin that gives the 747 its unmistakable profile, was shattered and fell in pieces into Sagami Bay below. And in doing so, it severed all 4 hydraulic lines simultaneously. The Boeing 747 has 4 independent hydraulic systems, 4 separate circuits carrying pressurized fluid to the flight control surfaces: the rudder, the elevators, the ailerons, the spoilers. The reason there are 4 is redundancy. Lose 1, you have 3. Lose 2, you have 2. The probability of losing all 4 simultaneously was considered by Boeing's engineers to be essentially impossible. All 4 gauges read 0. Without hydraulics, Captain Takahashi had no rudder, no elevators, no ailerons, no spoilers. He could not steer the aircraft. He could not control its pitch. He could not do anything that a pilot is trained to do. The only inputs that still worked were the throttles, the levers that control engine power on each of the 4 engines individually. By advancing or retarding specific engines, a pilot can theoretically induce turns and control pitch. It is extraordinarily difficult. It has never been practiced in a 747 simulator. It exists in no emergency checklist, and it has to be done with a precision that is nearly impossible to achieve while simultaneously managing an emergency descent, an aircraft full of terrified passengers, and a radio frequency full of controllers asking questions. Takahashi declared an emergency. He requested an immediate return to Haneda, and then he and his crew began fighting. On radar screens across Tokyo, controllers watched Flight 123 trace an erratic path through the sky northwest of the city. It climbed, it descended, it turned one way, then corrected, then overcorrected other way. It was tracing the signature of a phugoid oscillation, the deep roller coaster motion of an aircraft that cannot control its own pitch, combined with desperate throttle inputs from a crew trying to impose their will on a plane that had stopped responding. The cockpit voice recorder captured what was happening in the flight deck. There were no screams, no panic. What the recording captured was the sound of professionals working, calling out instrument readings, coordinating throttle inputs, running checklists, communicating with controllers. Takahashi told his crew to keep trying. They kept trying. Passengers, meanwhile, had understood what was happening faster than the crew might have hoped. The explosive decompression, the oxygen masks, the wild motion of the aircraft, these were not experiences that lent themselves to reassurance. Some passengers wrote farewell notes. One man, a manager named Hirotsugu Kawaguchi, wrote to his wife and 3 children in careful handwriting. He told them he had no regrets. He told them to take care of each other. He told them not to be reckless. He never finished the note. At 6:42 p.m., 18 minutes into the emergency, the crew managed to lower the landing gear. This was deliberate. The gear creates drag, which helps stabilize pitch. It worked, to a degree. The oscillations became slightly less severe, but the aircraft was now lower, and it was over the mountains. At 6:49 p.m., the crew spotted an opening, a valley between the peaks of the Kanto Mountains. Takahashi aimed for it. If they could thread through the valley and reach flatter terrain, there might still be a chance. They almost made it. At 6:56 p.m., traveling at approximately 340 knots, the right wing of Flight 123 clipped the ridge of Mount Osutaka. The aircraft cartwheeled into the mountainside. The fuselage broke apart. The forward section slid into a ravine. The rear section tumbled over the ridge and came to rest on the far side. Fire broke out almost immediately. It was 6:56 p.m. It was still light outside. Here is something that the official reports tend to state quietly without dwelling on it. Of the 524 people on board Flight 123, somewhere between 20 and 50 survived the initial impact. They were alive in the wreckage. They were injured, some severely, but they were alive. They were calling out to each other. Yumi Ochiai, in the debris of the rear section, regained consciousness and could hear people around her. She could hear a boy and his mother calling to each other in the darkness. At 7:33 p.m., 37 minutes after the crash, a U.S. Air Force C-130 crew from Yokota Air Base located the burning wreckage. They had been monitoring the distress calls and had launched immediately after the crash. They radioed the coordinates. Yokota dispatched a rescue helicopter. At the same time, Japanese authorities were coordinating their own response. The crash site was in remote mountain terrain in Gunma Prefecture, accessible only by narrow forest roads. A Japan Self-Defense Forces helicopter was dispatched to search. What happened next depends on which account you read and which official statements you believe. What is not disputed is this: a rescue helicopter reached the crash site while it was still possible to see from the air. The crew saw the wreckage. They assessed the terrain: steep, densely forested mountainside with no landing zones nearby. They reported seeing no signs of life. They turned around. At the Yokota Air Base, U.S. military personnel had been standing by. They were never called by Japanese authorities. On the ground, rescue teams assembled. A makeshift staging area was established. Equipment was prepared. Helicopter landing ramps were constructed. Personnel were organized. The teams were positioned at their staging area, 63 kilometers from the crash site. They were told the rescue would begin in the morning. The sun set. The temperature on the mountain dropped. It began to rain. In the wreckage, Yumi Ochiai heard the helicopter sound fade into the distance. She heard the voices around her, one by one, go quiet. Keiko Kawakami, the 12-year-old girl, had been thrown from her seat on impact and had landed in a tree. She was injured and in shock, but alive. She could see helicopter lights. She tried to wave. Nobody saw her. She eventually drifted into unconsciousness. The night lasted 14 hours. When ground rescue teams finally reached the crash site the following morning, they found 4 survivors: Yumi Ochiai, Keiko Kawakami, a mother named Hiroko Yoshizaki, and Hiroko's 8-year-old daughter, Mikiko. All 4 were in the rear left section of the aircraft, rows 54 through 60. All 4 were seriously injured. Medical examiners who subsequently performed autopsies on the victims found extensive evidence that many passengers had survived the impact and then died during the night. Some had injuries that, treated promptly, would not have been fatal. Some had died from hypothermia. Some had died from shock that hours of medical attention might have reversed. One doctor said it plainly: "If the discovery had come 10 hours earlier, we could have found more survivors." Those words fell on Japan like a verdict. The investigation was thorough and ultimately conclusive. The aft pressure bulkhead had failed due to fatigue cracking that originated in the improper Boeing repair performed 7 years earlier. The evidence was physical, technical, and undeniable. Boeing accepted responsibility. The company acknowledged that its technicians had deviated from the approved procedure. 1 row of rivets instead of 2. JAL accepted partial responsibility for maintenance inspections that had failed to detect the developing cracks over 12,319 flights. In Japan, the response went beyond corporate accountability. JAL's president resigned personally. A JAL maintenance manager took his own life, leaving a note that cited the accident. The engineer who had cleared the aircraft as airworthy after the 1978 tail strike, also died by suicide. The aviation industry changed. Inspection procedures for pressure-bearing structures were overhauled worldwide. New techniques for detecting microscopic fatigue cracks were mandated. The concept of damage-tolerant design, engineering aircraft to survive partial structural failure, was strengthened substantially. The routing of hydraulic systems was reconsidered, so that a single failure point could not sever all 4 circuits simultaneously. 4 years later, a United Airlines DC-10 lost all 3 of its hydraulic systems when an engine fan blade failed catastrophically over Iowa. The crew, one of whom, a Czech pilot named Dennis Fitch, had specifically studied the case of JAL 123 and practiced engine-only control in a simulator, managed to crash land at Sioux City with 184 survivors out of 296 people on board. The techniques they used, improvised, under pressure, were techniques that the crew of Flight 123 had pioneered in 32 minutes over the mountains of Japan. Fitch later said that what the JAL 123 crew had done was, in his assessment, extraordinary. Japan Airlines built the Safety Promotion Center at Haneda Airport. It contains pieces of the wreckage, photographs, recordings, and the farewell notes that passengers wrote during those 32 minutes. The notes are displayed with extraordinary care. They are, the center's staff will tell you, the most important things in the building. The note from Hirotsugu Kawaguchi, the manager who wrote to his wife and children, who told them he had no regrets, who told them to take care of each other, was found in the wreckage and returned to his family. It is incomplete. He was still writing when the aircraft hit the mountain. Every August 12, a memorial gathering is held near the crash site on Mount Osutaka. Family members of the victims climb the mountain. JAL representatives attend. The 4 survivors, who are still alive, carry with them the memory of a night that the rest of the world has largely forgotten. A night when helicopters flew overhead and turned around, when the ground teams waited for morning, when the voices in the wreckage grew fewer and fewer until there were only 4 left. The margin between those 4 and the 520 is, ultimately, 1 row of rivets, a strip of metal, a dozen fasteners, each smaller than a human thumb. In aviation, the consequences of a mistake do not stay proportional to the size of the mistake. A shortcut taken on a routine repair, on a routine afternoon, in a maintenance hangar that no one remembers. These are the things that fill memorials. These are the things that fill mountains. Flight 123 left Haneda Airport on August 12, 1985. It never arrived in Osaka. The people it was carrying are remembered every year by the families who went to the airport to meet them and waited for a flight that never came. They are still waiting, in the way that grief never fully resolves, in the way that a missing person never entirely stops being expected, even when you know. Even when you know.